1 minus data over data to the power of 9, and the next factor will give 1 minus data over 25 and minus 1 minus data over 10 to the power of 6. And the last factor here, this will give me 1 minus, when x approaches infinity, this becomes 0. And minus 1 minus data divided by 25 to the power of 5. So simplified.
Okay, class, you please take note here. This is our first CDF at the list value here. This must be 0. Okay, the CDF at the list value here must be 0. So the list value, as I say, is not data divided by 0. That's wrong, right? Because our x, the list value of x is data, so here will be 0. Okay, and next, f infinity must be 1. Okay, if you couldn't get this is 1, if you couldn't get this is 0, then something wrong with your working. Okay, so this is a trick of this. Next.
This, we will have 1 minus data over 10 to the power of 9, and this is data over 10 minus data over 25 to the power of 6, and this is data over 25 to the power of 5. And this will give the result as 3 to the power of 6 times 10 minus data to the power of 9 and multiply data to the power of 11 divided by 10 to the power of 9, 50 to the power of 6 times 25 to the power of 5. Hence, the log likelihood functions, which is given by the following. So we take log, then we will have log 3 to the power of 6 divided by 10 to the power of 9 times 50 to the power of 6 times 25 to the power of 5, and plus 9 times log 10 minus data, and plus 11 log data. Thus, we differentiate the log likelihood with respect to data.
Okay, class. When you take log, this is a constant. You don't need to use calculator to simplify this, okay? The whole constant after you differentiate becomes 0. Okay, so that's why this you no need to simplify, just leave it like that, because later on it becomes 0 after differentiate. Carry on.
This will give 0, and next this will give me 9 divided by 10 minus data, and multiply the coefficient of negative data, so we have negative, and plus 11 over data. And next we go to second order. So this will give me 9 divided by 10 minus data square and minus 11 over data square. Now, if the slope equal to 0, therefore this equal to 0 as well. And I will have data which is 5.5. So therefore, the second order at 5.5, which is equals to this value, which is negative, and therefore the estimate of data is equals to 5.5 under MLE.
Okay, very clear, right? So it's very easy, this topic. It's just a calculus. So the most important, you must know how to form the likelihood Okay, so under group data, in complete data, you have to do this way. Okay, so it's very simple. Individual, we multiply the PDF or maybe PMF. Okay, for this group data, we have to consider the probability in that interval. Okay, to form the likelihood function. Next, either you want to take log or not, it's up to you. Okay, for this question, if you don't take log, if you use quotient rule, okay, you also can solve the problem. Okay, but I think maybe quite complex. You are working. Okay, so that's it for this example 3, and based on the group data. So next, I will go to the combination, the mix problem with this individual and group data. So certain problem we can mix together, group and individual. Okay, so we try to go to next. Okay.